Imagine hurtling through the endless void of space, billions of kilometers from home, on a tiny spacecraft built with technology from the disco era. That's the reality of Voyager 1, humanity's farthest ambassador, still whispering secrets from the cosmos after nearly half a century. Launched on September 5, 1977, this intrepid explorer has defied the odds, traveling over 25 billion kilometers, equivalent to about 167 astronomical units, where 1 AU is the distance from Earth to the Sun. As of September 2025, its faint signals take a staggering 23 hours to reach us here on Earth, a testament to just how far it has ventured. But what if I told you that even now Voyager 1 is unveiling mysteries at the edge of our solar system that challenge our understanding of the universe? Stick with me through this cosmic journey, because by the end, you'll see why this aging probe might hold the key to unlocking the next era of space exploration. We're diving deep into its history, its groundbreaking discoveries, and the mind-bending data it's sending back today. Data that could rewrite the rules of physics as we know them. Let's start at the beginning to truly appreciate the epic scale of Voyager 1's odyssey. Back in the late 1970s, NASA engineers dreamed big. The Voyager program was designed to take advantage of a rare planetary alignment that occurs only once every 176 years, allowing a single spacecraft to slingshot past multiple outer planets. Voyager 1's primary mission was to study Jupiter and Saturn up close, capturing images and data that would revolutionize our view of these gas giants. On March 5, 1979, it flew by Jupiter, revealing volcanic activity on its moon Io, the first active volcanoes discovered beyond Earth. Then in November 1980, it skimmed past Saturn, unveiling intricate details of its rings and discovering new moons. These encounters weren't just snapshots. They provided invaluable insights into planetary atmospheres, magnetic fields, and the dynamics of ring systems. But Voyager 1 didn't stop there. With its planetary flybys complete, it was flung outward on a trajectory that would carry it beyond the solar system, into the uncharted territory of interstellar space. Fast forward to August 25, 2012, a milestone etched in space history. That's when Voyager 1 officially crossed the heliopause, the boundary where the sun's solar wind gives way to the interstellar medium. This invisible frontier marks the end of our solar system's protective bubble, known as the heliosphere, which shields us from harmful galactic cosmic rays. Crossing it meant Voyager 1 became the first human-made object to enter interstellar space, a realm dominated by the winds and particles from other stars in our Milky Way galaxy. As of July 2025, the probe was clocked at a speed of about 17 kilometers per second, continuing its relentless push into the unknown. And here's where it gets truly captivating. Even with its antiquated instruments, designed in an era before smartphones or the internet, Voyager 1 is still operational, sending back data that scientists pore over with excitement. In fact, as recently as May 2025, NASA engineers at the Jet Propulsion Laboratory revived a set of backup thrusters that had been dormant for decades, ensuring the spacecraft could maintain its orientation and continue communicating with Earth. This feat alone is a marvel of engineering ingenuity, keeping the mission alive against all odds. But what exactly is Voyager 1 encountering out there? The heliopause isn't a sharp line. It's more like a turbulent frontier, and the data from Voyager 1 has revealed surprises that keep astronomers up at night. One of the most intriguing findings is the so-called Wall of Fire, a region where temperatures soar to around 90,000 degrees Fahrenheit, about 50,000 degrees Celsius, far hotter than expected. This isn't literal fire, of course, but a plasma boundary where charged particles from the solar wind collide with interstellar material, creating intense heat and energy. Scientists confirmed this through Voyager's instruments, which detected a sudden increase in plasma density and a shift in magnetic fields. What's puzzling is that the magnetic field in interstellar space seems to remain partially connected to the sun's, defying models that predicted a clean break. These observations suggest the heliopause is more dynamic than we imagined, with fluctuations that hint at ongoing interactions between our solar system and the broader galaxy. Delving deeper, Voyager 1's plasma wave science instrument has picked up subtle vibrations, essentially hums in the interstellar medium, that indicate low-level activity persisting far beyond the heliopause. In 2021, for instance, it detected plasma waves generated by interstellar gas, providing the first direct measurements of the density of material between stars. Updating to more recent data, as of 2025, ongoing analyses show these waves continuing, with patterns that suggest the interstellar medium isn't as uniform as once thought. There are hints of density variations, possibly influenced by supernova remnants or nearby stellar winds. Imagine, our solar system isn't an isolated bubble, but part of a vast, interconnected web where galactic events ripple through space, affecting even distant boundaries like ours. These findings aren't just abstract. They help us understand how cosmic rays, high-energy particles from exploding stars, penetrate our heliosphere, potentially impacting Earth's atmosphere and climate over eons. Now let's amp up the intrigue. What if these magnetic fluctuations and plasma anomalies point to something even more profound? Scientists have theorized that the heliopause might be compressed or shaped by external pressures from the local interstellar cloud, a diffuse region of gas and dust our solar system is plowing through at about 23 kilometers per second. Voyager 1's data supports this, showing unexpected alignments in magnetic fields that could indicate interactions with this cloud. In a 2024 study published in the Astrophysical Journal, researchers using Voyager data proposed that these fields create a sort of magnetic highway, allowing cosmic rays to stream in more efficiently than predicted. Fast forward to 2025, and NASA's latest updates confirm that Voyager 1 is still detecting these rays at levels higher than anticipated, suggesting our models of galactic radiation need a serious overhaul. This isn't science fiction, it's real data challenging our grasp of astrophysics. Could these phenomena be echoes of ancient supernovae, or even signs of undiscovered dark matter influences? The possibilities are endless, and each new transmission from Voyager 1 adds another layer to the puzzle. Of course, no discussion of Voyager 1 would be complete without acknowledging its twin, Voyager 2, which entered interstellar space in November 2018. While Voyager 1 took a more direct path northward out of the ecliptic plane, Voyager 2 veered southward after visiting Uranus and Neptune, the only spacecraft to do so. Together, they've provided a stereo view of the heliosphere's asymmetry, revealing it squashed on one side due to interstellar pressures. As of September 2025, Voyager 2 is about 20.9 billion kilometers away, 139 astronomical units, with signals taking around 19 hours to arrive. Both probes carry the famous golden records, time capsules with sounds, images, and greetings from Earth, designed by Carl Sagan and his team. These records, etched in gold-plated copper, include everything from Bach's music to whale songs, a universal message to any potential extraterrestrial finders. Though the chances of discovery are slim, space is vast, the records symbolize humanity's hope and curiosity. Despite their age, the Voyager's resilience is nothing short of miraculous. Powered by radioisotope thermoelectric generators using plutonium-238, their energy output decays over time. By 2025, power levels are critically low, with NASA predicting that all scientific instruments will be shut down between 2025 and 2030. After that, the probes might still send faint engineering signals until around 2036, when they'll fall silent forever, drifting as eternal monuments to human ingenuity. Yet, even in their twilight, they're yielding gold. A December 2024 incident saw Voyager 1 pause communications due to a fault protection trigger, but engineers quickly restored it, resuming science operations. This event underscored the challenges of commanding a spacecraft from such distances. Every instruction must account for the round-trip light time of nearly 2 days. Think about the human element behind this. The team at NASA's Deep Space Network, massive antennas in California, Spain, and Australia, listens tirelessly for Voyager's whispers, which arrive at a mere 23 watts, weaker than a refrigerator bulb. Suzanne Dodd, the project manager, has described the mission as like caring for an elderly relative, requiring creative problem-solving to extend its life. In May 2025, when primary thrusters clogged with silicon dioxide buildup from aging components, the team switched to long-dormant backups, a risky maneuver that succeeded brilliantly. These stories of perseverance inspire not just scientists, but dreamers everywhere, reminding us that exploration demands patience and innovation. Shifting gears, let's explore the broader implications. Voyager 1's data is reshaping our view of the universe's structure. The interstellar medium, once thought empty, is alive with plasma oscillations in magnetic turbulence. A 2025 paper from the Voyager team, presented at the American Astronomical Society meeting, highlighted unexpected electron density increases, possibly from compressed regions in the local cloud. This could mean our solar system is navigating through a fluffier part of the galaxy than expected, with implications for how stars form and evolve. Moreover, understanding the heliosphere's boundaries helps protect future missions. For instance, knowing cosmic ray fluxes is crucial for crewed voyages to Mars or beyond. And speaking of the future, Voyager 1's legacy fuels visionaries like Elon Musk, whose SpaceX endeavors aim to push humanity farther. While Musk hasn't made specific public statements on Voyager's latest data in 2025, his long-standing admiration for space exploration is clear. In past interviews, he's highlighted how probes like Voyager inspire Starship's design for interstellar potential. Musk's goal of making humans multiplanetary echoes, Voyager's spirit, venturing into the unknown to ensure our survival. Imagine, data from Voyager could inform propulsion tech or radiation shielding for future starships. As Musk often says, the universe is vast and full of mysteries. Voyager proves we're capable of unraveling them. But here's a thought that might send chills down your spine. What if Voyager's findings hint at life beyond our solar system? The probe hasn't detected aliens, but its measurements of interstellar chemistry, organic molecules and water vapor in distant clouds, bolster the case for habitability elsewhere. If the heliopause interacts with galactic phenomena, could it shield or expose potential biospheres? We're not alone in wondering. Astrobiologists use Voyager data to model exoplanet environments. Every signal from Voyager edges us closer to answering humanity's oldest question: are we alone? As Voyager 1 fades into the cosmic night, its journey reminds us of our place in the grand tapestry. We've sent a piece of ourselves into infinity, carrying hopes, dreams, and knowledge. Though its power wanes, the questions it raises will propel generations forward. What unseen forces shape our galactic neighborhood? How will we follow in Voyager's wake? The answers lie ahead, waiting for bold explorers. If this tale of cosmic wonder has captivated you, don't stop now. Hit that subscribe button and ring the bell for more mind-expanding adventures. From black holes to exoplanets, we've got impossible discoveries lined up. Share your thoughts in the comments. What do you think Voyager will reveal next? Let's keep the conversation going, because the universe's secrets are endless, and together we'll uncover them all.